Hello, my name is Soumya and I welcome you to Revisedu, the learning platform. In today's video lecture, we are going to see a principle which is known as principle of superposition for electric forces. So in the previous videos, we have derived various formulas for forces. But which type of forces were we dealing with? We were dealing with electric forces or force of electrostatics or the electrostatic force. Electrostatic refers to the force which is actually dealing with electric charges at rest, means they are stationary, they are not changing their position with respect to time. Fine. So what we have derived was that this force, we have done in Coulomb's law also, that force is equal to K Q1 Q2 by R square, or we can say 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is what we have derived, and this was what? This was electric force. Now if a body is having many charges and it is experiencing many forces due to that charges, right? So what is going to happen? What will be the total force of that body? So this is actually the principle. This is actually the funda which is going to tell you that how we can say when we have many n numbers of charges and n number of forces happening on a body, then the total force can be said to be what? Okay, so we are going to do this in this principle. So now let us talk about the principle, what it states. So it states that the net force. So what the principle says is that the net force is on a given charge. The net force on a given charge. We know that forces on charges are due to the presence of other forces, right? So if we are having n number of charges in the body, so the net force is going to be how much? The net force on a given charge is going to be equal to your vector sum of y vector, because we have seen that a force is a vector quantity when charges are a vector quantity, right? So when charges are vectors, then force is going to be vectors, and when there are multiple number of charges, multiple number of vector forces, so the net force on a given charge is going to be equal to the vector sum of the forces acting on that body, right? Acting on it by all other charges. So by all other charges. So this is what we have discussed, right? That if a body has multiple number of charges, there are going to be n number of forces. So at that particular time, the net force on a given charge is going to be the vector sum of all the forces which is acting on the body, right? Why the force acts? The force acts due to the presence of another charge, right? So that is why we have written this line, that all other charges. So the effect of all other charges is going to be seen on a charge, right? So what we can say in mathematical form is that F, which is F is your net force, is equal to F1 vector plus F2 vector, and the body is going to have what? N number of forces, right? So we are going to write Fn vector. So what is this? This is the net force on a body, net force, right? So this is what the principle says. The principle is very simple, but its concept is applied when there are many number of charges, right? And when the forces are represented in vector, means you know both the magnitude of the vector and the direction, because we have already studied that vectors are those quantities which have both magnitude as well as the direction. So for such quantities, we are using a vector summation, right? I hope that this concept of principle of superposition for electric forces is clear to you. Thank you.